Hello there, Gregory Carlson here for College Algebra 3.1 Part 2. So we just looked at two examples, one in vertex form and one in standard form. So let's generalize it. And so this is some stuff you need to memorize, so I'm going to put a star by it. So if our vertex is in standard form, which means ax squared plus bx plus c, then remember how I said to find the vertex. The x part of the vertex is the amount negative b divided by 2a, and it's always that amount. Then to find the y part of the vertex, you plug in negative b over 2a. So I'll represent that by putting f of negative b over 2a, but basically that just means plug it in. So the vertex for a standard form parabola is negative b over 2a for the x part and f of negative b over 2a for the y part. In other words, plug in x. Plug in that x value you get. The axis of symmetry then is x equals negative b over 2a as well. And remember, the axis of symmetry is a line, whereas the vertex is a point. Vertex form is easier. You'll notice that there's a minus right there. So the vertex for that is you flip the sign of the number in the parentheses that's being added or subtracted, but you keep the sign of whatever's being added or subtracted on the end. So that's why that's a minus and that's a plus. So the vertex is hk, and the axis of symmetry is simply x is equal to h. So that's a lot easier if it's in that form. The way you go from this form to this form is you FOIL this. Notice, by the way, that there's an a right there. So that is the same a as that a. The way to go from here to here is to FOIL this and simplify. The way to go from here to here is to complete the square, which we looked at a little bit, and we'll look at a little later. To find the y-intercepts, you basically just plug in 0 for x and find out what number it is. The y-intercept is usually pretty easy to do. To find the x-intercept, what we need to do is plug in a 0 for y and solve. And oftentimes we'll need to factor or do the quadratic formula. By the way, as we're about to see, there's not always going to be x-intercepts. All right, in fact, let's look at that now. There's a special amount called the discriminant when we're talking about quadratics. And the discriminant is this special number called b squared minus 4 times a times c. If you're familiar with the quadratic formula, you should recognize this amount. Let's say we're trying to find out if there's going to be any x-intercepts. When are we going to hit the x-intercepts? Well, if this b squared minus 4ac is bigger than 0, what's going to happen is we are going to get 2 intercepts. So that's what happens when b squared minus 4ac is bigger than 0. And you might be wondering where this crazy number is coming from. We'll find out later. If b squared minus 4ac is exactly 0, then that means that the vertex is actually on the x-axis. And so we have exactly one x-intercept at that only one place where we touch. If the discriminant is less than 0, then that means we don't have any intercepts at all. And so we get a situation like that. So those are the three possibilities: 2 intercepts, 1, or 0. These scenarios are also there for parabolas opening down. So you could have a parabola opening down that has 2 intercepts, or 1 intercept, or no intercepts at all. By the way, you'll notice that the vertex, in addition to being the maximum or the minimum, is where the graph goes from decreasing to increasing. So the vertex is what separates the decreasing from the increasing, or if it's opening down, it's what separates the increasing from the decreasing. Okie dokie, I have time for an application problem, so let's do it. This is a very special formula. It's the vertical height formula. This is from physics. If we ignore air resistance, then the height of an object that you throw straight up in the air, so a rock or a spoon or whatever you want, h of t, the vertical height, is equal to this formula. It's negative 16t squared, and this negative 16 it comes from the force of gravity, plus the initial velocity, that's what VO means, initial velocity, plus your starting height. And so we can use this formula to really accurately predict the vertical trajectory of objects. It's kind of cool that it's actually this simple. Gravity is actually not too difficult to solve. So let's look at an example. A rock is launched by a slingshot from the top of a tree 51 feet tall. So that number is going to be my initial height. And by the way, sometimes you see people put an S there instead of H. I don't really know why that is. I like H for height, but whatever. It has an initial velocity of 38 feet per second. Give the function that describes the height of the rock in terms of time. So let's do that. That formula is going to be h of t is equal to, this first term is always negative 16t squared because of gravity. By the way, that's if we're doing feet per second, this is negative 16. If we're doing meters per second, it's a different number. It's negative 4.9 if it's meters per second. Anyway, the initial velocity they tell us is 38. So we add 38. So I put in a 38 for the initial velocity, and our starting height was 51 feet. So with that formula right there, we can plot the entire trajectory of the vertical change of the rock's movement. So there's the equation. Determine the time the rock reaches maximum height. So just to show what's going on here, draw a little picture. We started in a tree 51 feet tall. The rock was slung up with our slingshot, and then at some point we'll hit the ground. So here's time, and here is height. So they want to know at what time will the rock reach its maximum height. And that point should look familiar to you. It's the vertex. So all we need to do is find the vertex of this thing. And you'll notice that we're in standard form, so we're going to use this magic negative b over 2a again. So let's do that. So here's A, here's B, and here's C. So the vertex is going to be negative b over 2a, which will equal negative 38 divided by 2 times negative 16. So I have two negatives, that'll make a positive. So that's going to be 32 on the bottom. So let's do 38 divided by 32. So we get a time of t. The vertex is going to be 1.1875 seconds, which is pretty fast if you think about it. If you do a slingshot up at an initial velocity of 38 feet per second, it's going to be at its maximum height just after a second. So this time right here is 1.1875. So that's the answer to that part. State the maximum height. Well, the maximum height is going to be the y value when we plug in this time. It's the y part of the vertex. So let's plug that in. Negative 16 times 1.1875 quantity squared plus 38 times 1.1875 plus 51. Crunch all of this out, and we're going to get our height when we find the vertex, that maximum height. So let's do that. Let's do 1.1875, and then let's square that number, order of operations, times negative 16. So this first number is going to be negative 22.5625. Now let's do 1.875 times 38, and we get 71.25 positive, and then plus 51. So let's add these three numbers together. Let's add 51 equals, and then we'll subtract 22.5625. And so the maximum height is going to equal 99.6875. And so that's that height value right here. It's going to be 99.6875. That's the height when we hit that maximum time. For what interval will the rock be more than 60 feet above the ground? For what interval will the rock be more than 60 feet above the ground? And finally, after how many seconds will it hit the ground? Well, these are two interesting questions. So here's 60. 60, I don't know, will be about here. So they want to know, for what interval of time will we be above 60 feet? Do you see that? So they want to know this time here, and they want to know this time here. So that's going to be kind of tricky. I see them already at 10 minutes. So let's answer these questions in part 3.